this we will spend today and tomorrow on, and then we will take our first test on Tuesday next week. So Monday will be a review day, and then we'll take our test over the review stuff. So, properties of exponent. What's anything to the 0 power? 1. I'm pretty sure this is not supposed to be x negative, it's supposed to be a negative x. Sorry about that typo. So what's a negative exponent do?
Flips.
So it's 1 over a to the x power. What's a fraction exponent mean? If I said like 5 to the 2/3, how do we write it? What about if it was the 1/2? What's a 1/2 power mean?
We don't know.
Yes, you do.
We're really trying here, Miss Apple.
Oh.
So
the cubed root
and
is
then squared, yeah. Okay.
And the square could be inside or out. All right. If you're multiplying and you have the base written each time, what do you do with your exponents?
Multiply.
Add.
When you're dividing, what do you do?
Subtract.
Oh my God. You can't.
Power to a power, what do we do?
Multiply.
If you have two things in your parentheses, what do we do with the exponent? If it's more than one term, so if it's like x plus 3 squared, you have to FOIL, but if it's 3x, you could square both pieces. All right, so far so good? So let's simplify. So where would we begin here?
Start by doing the
Parentheses.
Okay. And what do I need to do with that cube? Distribute it to both. So what's 3 to the 3rd? Going to be x to the 6. Then when I multiply these, what do I do with my exponents? Add them. So 27 x to the 10. All right, B. If I multiply these, add our exponents. So 2n plus 3n is 5n. So we'll have that minus 1. If we divide, what do I need to do with the exponents? Subtract them. So I'm thinking about bringing this up. I have to subtract off this n plus 2. So what would I need to do with that? Distribute the negative. So 5n minus n is 4n. Negative 1 minus 2 is negative 3. So x to the 4n minus 3. C. If I wanted to do this without just grabbing a calculator, how do I rewrite it? What is the cube root of 8?
2.
And to the 4th power? P. So let's start here. That has a negative exponent, so where does it go? Alright. So then if we start distributing these exponents. 5 squared is 25. Be x to the 8. Bottom 3 cubed is 27, x to the 6. 5 times 25, 125. X to the 0 times x to the 8th is just x to the 8th. Now what? Since I have x's on top and bottom, we can reduce those. 8 minus 6 is 2, so it's an x squared. How much of this are you guys remembering?
Every single bit.
Oh, you must have had an amazing teacher. It's gotta
Something
be
like
what
that.
it is. Alright, let's look at this one. So, the negative exponents would flip it. So we have 2 to the 8th over 4 cubed. If I put this on your test, and you know you can't have a calculator on your test, do you have any suggestions for
We're gonna
working it?
add two to itself, 8 now.
Multiply it.
You could multiply now, 2 to the 8th, and work that out. Work out 4 to the 3rd, and then reduce it.
Yeah.
Exponents have to come before division, so we would have to apply those exponents before we just divided the 2 and the 4.
Oh, I know what we're supposed to say.
What?
Change 4 to 2 to the 2.
Oh, you make me so happy.
Well, good thing I didn't stay home then.
You can stay home.
I was at home and I came back.
Are you not feeling good?
Oh, my pubes this morning.
I don't really want you here then.
No, it was at practice. It was a practice puke.
Okay.
Well, I didn't see that.
What do you mean? How did none of the boys see it? I literally, we got done running the 400 and I ran over to the gate and just started throwing up.
So we can change that 4 to a 2 squared. Then 2 squared cubed becomes 2 to the 6th. So what's that turn into?
2 to the 2. 2 squared.
Empty the trash cans after meets.
Hmm?
I feel bad for the guy who's like empty the trash cans after meets and practices and stuff. Most
Yeah.
people
Except
just
the
help
thing
you.
is nobody makes it to the trash can.
That's true.
Yeah.
The people that golf on that golf course though, like after we get done running on them.
Rip.
Alright.
Flat rim, isn't it?
Great. What would we do on this one?
Got me stumped again.
Can we change each exponent to a fraction?
Yeah. Instead of a square root, let's write it as a fraction. So on the top, this whole thing is under 1 square root. What power is a square root?
2.
1/2.
Oh.
Okay. Then under that we have an x, but then I have a second square root. So this xy is also to the 1/2 power. Is everybody with me there?
Sure.
On the bottom, this was all under a radical. What power would we do? It's 1. So now let's start cleaning this up. If we distribute, so on top, I have x times x to the 1/2 times y to the 1/2, all to the 1/2. And the bottom, that's x to the 3/4, y to the 5/4. On the top, can I combine these x's and distribute my half at the same time? So x times x to the 1/2. What would you do with those exponents? Add them. So 1 plus 1/2 is 3/2. 1 is like 2/2 plus 1/2. Then you have to multiply that by 1/2. So 3/2 times 1/2. What's that give you?
3/4.
So it's x to the 3/4. Y to the 1/2 times 1/2 is 1/4. Okay, if anybody doesn't know how to multiply fractions, you need to speak up now.
Wait.
You sure?
Yeah.
It's just the fact that she's like, wait, hold on.
No, I was looking at the wrong thing.
No, because I respect it if you did have to think it over, because honest to God, I'm sitting there like, I think I know it, but also at the
It's been
same
a
time,
minute.
am I going to hate myself in like 10 minutes when I have to ask what I ask?
What do we do with these x's?
They cancel.
What do you do with the y's? Where do you have more, on the top or the bottom? So I'm going to take it down to the bottom, which just leaves the 1 on top. So then it's 5/4 minus 1/4.
Just
Which is just
walk
one.
over first.
So we get 1 over y.
There's a lot of work for us to play.
See, do you know what I don't understand? Do you know how long it takes them to make these problems? Like, you gotta really complicate it up.
What if they just slap down some random numbers and just hope you can solve them?
Alright, is this good with everybody?
Yeah, I guess.
Okay, next thing. So we're talking about exponential functions. We need to be able to graph them. So if you remember when we graphed exponential functions, we always made a t-chart and plugged in 3 points. What were those 3 points?
0.
0, -1, and 1. Alright. So let's graph this function, find its domain and range. I want to do the parent function first and use transformations just for good practice. Is that okay? So my parent function would just be 2 to the x power. And so we always plugged in the -1, 0, and 1. What's 2 to the -1 power?
1.
What's 2 to the 0 and 2 to the first? So we have -1, 1/2, 0, 1, and 1, 2. Remember parent functions, they keep increasing. Here, will you do 2 to a power and get 0 out? Do you get negatives? No. So this was a horizontal asymptote. Now, we need to figure out our transformations. So think of this as -2 to the x plus 3. What does the plus 3 do? It would be up, right? To be left and right, it would have to be added in with the x and the exponent. What does the negative in front do?
Flip it.
Over.
X.
Okay. So we're going to flip and then move up 3. My asymptote is currently on the x-axis. Where will the asymptote end up? I currently have a horizontal asymptote right here.
Oh, it'll be at 3.
We're going up 3, so it will move that asymptote up 3. So take my point, flip it over the x, and up 3. So that gives us our final graph. And what's the domain of that? Domain is left to right, so negative infinity, positive infinity. Range, what y values do we hit?
3, 2, no, negative.
Good. And then 3, whoops, we get a parenthesis because we don't ever actually touch that. All right. I've got one for you guys to try. So grab that.
Fancy.
What's your parent function?
3, 2, 9.
All right, so 3 to the negative 1 is 1/3, 3 to the 0 is 1, 3 to the first is 3. What's my transformation?
Just,
Yeah, this is 3 to the x with the minus 2 on the end, so it would go
oh.
down. Left and right, it would have to be like x minus 2 in the exponent. So here is my current horizontal asymptote. If we move up or down, that will move. So we're going to move it down to negative 2. And then move each point down to. And hopefully your graph is slightly prettier than mine. Domain?
Oh, sorry.
Range?
Negative 2, 2.
Good. Is that all right with everybody? Next piece. We've talked a little bit about finding domains. So let's practice finding domains. We know that if it's a square root, what has to be true when we find the domain? Okay, so the thing under the radical greater than or equal to 0. So if I'm solving for t, we can subtract our 1. I would have to divide by a negative, which flips my inequality. Okay, we don't really have a great option here, but we could think about what we know about these graphs. 2 to the t. So what's 2 to the negative 1? 1/2. 2 to the first. Or sorry, yeah. 2 to the first is 2 and 2 to the 0 is 1. That's my graph. I'm asking when it's less than or equal to 1. Can you tell me on the graph where this is less than or equal to 1?
From 1 negative, or from 1 to 0.
Even this whole thing would work. 2.
Oh, there's an asymptote.
Yes, but we're talking about the x value. So it keeps going on the x-axis. So we know that 2 to what power equals 1? 0. So that means our t had to be less than or equal to 0. And the graph just kind of reinforces that. So it's everything from negative infinity to 0 with the bracket. one, it's a fraction, so what can't be true?
1.
Okay. So e to the t minus 1 cannot equal 0. So e to the t cannot equal 1. Can you tell me what t can't be? 0. If you want something to a power to equal 1, that means the power has to be 0. So far, so good? Let's do just a couple slides. So this e to the t, we know when we talked about like natural logs, and that was a log base e. So e to the x, they call that the natural logarithm function. Not that you really have to memorize that term, but in calculus, we see the e a lot because it comes up a lot in like population studies and things like that. I could ask you to graph these. E is just a number, kind of like pi. It has a set value. It's like a 2.7, and then it just keeps going forever. So if I want to graph this, we know it's an exponential. So we know, where does it have a horizontal asymptote? 0. We're going to have horizontal asymptote on the x-axis. So our parent function will be, if you put in a negative 1, e to the negative 1, so that's like a 1 over 2.7 something, so we're just getting something less than a half. E to the 0, anything to the power is 1. To the first, or e to the first would be like a 2.7-ish. What are my transformations this time? And the negative on the x? Over. So my asymptote was at 0, so if you move down 1, it would be at negative 1. So take my point, flip it over the y, down 1. The domain. And the range. Questions? So the next piece I have is logs. So why don't you go ahead? Let's at least talk about the properties, and then I'll save the last few examples for tomorrow. So the log is the inverse of the exponential. It means they undo one another. If I said log base a of x equals y, do you remember how to write this in exponential form?
You do a to the y power equals x.
Yes. Remember, you always start with the base. The base of the log and the base of the exponential are the same. You go across the equal sign. So a to the y equals x. Properties of logs. If you have a log of two things multiplied together, how do we break those apart? Yeah.
Oh, okay.
If you have a log of things being divided, what do? Log of the top minus log of the bottom. If you have an exponent in front, what do you do with that? Or x, said that. If you have an exponent, where do you put that? It turns into the coefficient. Common log is log base 10. Usually you don't see the base, it's just log. Natural log is what we will encounter more in calculus. That's natural log, ln. What that means is a log with a base of e. So those are the most common ones, but in calculus, I said already we're going to see that e a lot. So that is